Welcome everybody. I'm glad to be here. I hope you are too. I am Thomas Watkins. I am a UX practitioner who also specializes in data visualization. And so this talk is going to be talking about or getting into the imperative topics of the day. So I'd like to start off this story with this presentation with a story about someone named Mona Menkara. Mona Menkara, at the age of 7 years old, was diagnosed with macular degeneration and cone rod dystrophy. She was told as a young girl that she would not be able to achieve her dreams of being a scientist. Her mother was told by one specialist that it wasn't worth it to invest too much money in her education because she's not going to be able to achieve those dreams anyway. She went on to excel in school, got into college, majored in chemistry, and earned a PhD in chemistry. Today, she's a professor of bioengineering at Northeastern University at Boston. And less than 1 month ago, her and her colleagues introduced a way to use lithophanes. It's a certain ancient type of art dealing with stone carvings that light shines through, in a way to create data visualizations that her sighted students can see and she can also experience when they're dealing with graphics. I wanted to start off with this story because I thought it was an important illustration of how important accessibility is to data visualization, to everything, but especially to data visualization. It's not only those who need the accessibility who lose out when you don't do it, but it's also the whole world loses out from brilliant minds like Mona Menkara when we're not unable to transfer insights about data from one human mind to the next. So we're gonna get into that with some examples across the board and also talking about coming back to the lithophanes. Some digital examples of the state of data visualization. Now, I'm going to do my best to describe some of the more visual slides here so that everybody can experience this. The slide that I'm showing right now is a rather busy, in motion graphic of a dashboard, a visualization dashboard that's got all sorts of things about it, most of it wrong. Okay, so this is a situation where data visualization is kind of replaced by the goals of data art, where folks are trying to make things appear, entertaining, but it's not communicating as the main goal of data visualization is supposed to be. So this is the current state of data visualization, and that's not good for sighted people. Going to our next example, I'm going to play this, and I believe I have my audio hooked up so that you'll be able to hear this part. This one is a screen reader, this is going to be demoed, just a few seconds of a screen reader interacting with a dashboard.
And so tabbing at this point moves between the different components of the visual.
Graphic, plot area section.
And then I can decide, once I pick which component I want to explore further, I can just hit enter.
Product Amarilla. Sales 17,747,116.06, 14.95%.
And now section. I can tab between each of the individual data points to hear the data behind each slice of the donut.
Product Carretera. Sales 13,815,307.89, 11.64%.
Yeah, so that was just a clip of how, if somebody is using a screen reader, how they're likely to experience a dashboard. And that's one of the better case scenarios. Oops, let me go back in there.
And so tabbing at this.
Go to the next slide. Okay, so this is another example, and this is called sonification. I'm going to see if does that open it up? Okay, so here's an example of something called sonification. This is when data is taken and transformed into sound waves. So I'm going to play some examples of this before I comment on it. That's just a basic example that comes from this high charts playground that allows people to plug in data and to sonify it. The next sonification example I want to share with you is, let's see. Make sure the screen loads back. I think it's because of the link I clicked. This one is, this next example is from, whoops. This next example is from, when you click it, it also, I'm trying to rewind it by clicking it, and then it also starts playing it. Okay, so this is from a sonification of a data set that shows, is intended to show seismic activity over the course of a time period in Oklahoma. And the motivation behind this is that the increased earthquakes are related to increased fracking activity in a certain area. So I'm going to play this so you can hear the example. Each ping, I think, represents a tremor. Okay, I guess I could stop it there. There's a few more seconds yet left, but I think you get the idea of that. So that's the concept of data sonification. And the last example I'll talk about here in this set is the idea of tactile graphics. Tactile graphics can be done in general just with raised portions on a flat surface that map onto what sighted people would be seeing. And the opening example I gave you was lithophanes, which is an example where sighted people can experience it, and blind people also as well. And so the some insights from these is that there's a wide scope of ways and methods to communicate data. When we talk about data visualization and making it accessible, it intersects with some of these topics. The issue with a lot of the things presented here are either they're bad, as in the first cases of data visualization where it's not done well, and therefore it's difficult to perceive even for sighted people, fully sighted. But then there's also things that aren't maybe standardized, like data sonification. Data sonification is a very, very interesting idea. It may have applications in situations where there's complex data sets that would be hard to summarize in a lot of ways. And maybe that can be mapped onto some sonification technique where trained listeners are able to gain insight from the sonified data. So that has potential. Unfortunately, it may not be on the horizon that for most websites and most digital products that do data visualization can create something that's very accessible for people who need it. And the last example is a wonderful example, lithophanes. However, it may not be very scalable. One could imagine that we could have something in the future that's similar to Braille keyboards, where you have some digital interface that's a tactile surface that interactively it has a raised surface that people are able to interpret. Maybe that could be on the horizon. I think that would be revolutionary, but again, that's not an option for most folks today. So let's think about data visualization and the reason why we're doing this. We're trying to communicate data insights from one human mind to other human minds, right? And so let's take a look at the topics. I'm going to first go over kind of some of the subtopics. There's a lot of different subtopics when you're mixing data visualization and accessibility, a lot of potential things to talk about. What I've tried to do is put together kind of a framework for thinking about some of these subject topics and organizing them so that we can better think about and position these things. This in the context of the purpose of data visualization, the history of data visualization, and accessibility as this kind of blends and mixes together, understanding the problems and why they're problems, and then kind of proposing a method that I think is very achievable in the immediate term. So a bunch of different subtopics scattered around. So for folks who can't see, it's a set of short phrases that are kind of scattered around the screen, representing that this is kind of a disorganized array of ideas, right? So we've got things like signal detection theory, sonification, bits of data, bits of information, and I'm going to flesh some of these things out, redundancy, and so forth. So the framework that I want to kind of use for this is, right now I'm showing a two-dimensional table that goes from left to right, bottom to top. From left to right, it's representing progress of going from raw data on through organized data, and then all the way to visualized data. And, you know, and hopefully at the very end, it would be a data insight. Okay, so left to right, we're dealing with how, when we're working on data, do we need to progress this stuff along? And then going from bottom to top, we've got these tiers that I call the layers of facilitation. Layers of facilitation. This is what we have to think about in addition to just visualizing the data. What are the extra layers that we want to add on to make sure that everybody can share in the insights that are here? So at the bottom, I have fully cited, and then in the middle, partially cited, and on the top, blind. And so this is dealing with kind of a plane, an area of where we're thinking about what are we going to do with the data as we're processing it from raw to fully cooked, available visualizations and insights. And then what are the layers of facilitation that we have to think about along the way? Okay, and so to remind ourselves of the purpose of data visualization, one way of looking at this is that data visualization is accessibility. So the human mind is not very equipped for dealing with just raw data. If you think about just tabular data, numbers in a spreadsheet, we are not good at interpreting these things and gaining insights from them. Statisticians over the past centuries and really the 20th century developed a lot of ways to visualize data in a way that you can just look at it, a sheet of paper, and use your sensory perceptual and cognitive systems to automatically see patterns where we can start to interpret the data in an organized way. It's already accessibility, data visualization is. It's already an attempt to take something that's very, very difficult for us to perceive the way we are and putting it in a way that it's easier for us. So with that being said, if we just look over kind of a brief history of data visualization and UX, I'm showing this visualization that goes from left to right. It's a set of arrows. There's a big heavy arrow in the center going from left to right that represents ideal accessibility, excellent accessibility. It's the goal of where we would want to get. And as we go from left to right, we're moving forward in history. So the I have an arrow representing data visualization that starts off far away from the ideal center arrow and then gets closer to it over time. And then the same thing with human factors. Okay, so doing the data visualization history a little bit, or let's start with the human factors history. Human factors begins around the World War II era, and it marked a difference in thinking about how do we build things. We, during World War II, military, the mentality is that you are a military subordinate, you're a soldier, your job is to follow orders. And if there's a system or a machine that you need to use, you need to adapt yourself to the machine. No matter how it was designed, you need to learn how to do your work with these things that have been designed poorly. And then after enough airplanes crash and submarines explode, folks learned that it's important to actually have to consider the human factor, right? So when you're designing a system, you have all these different machine factors and process factors. When you need the human factors as well needs to be a part of the consideration. What of the imperfect human can we do to design things so that we're better able to use it? This evolves over the decades, mostly in the industrial world, and eventually becomes what we know today as UX. And just to give a example about how far we've come just in the past 10 years in UX, I'm showing a quote here of Jacob Nielsen from Mobile UX, a book 10 years ago. And I'm just going to read the highlighted portions here as he's talking about how bad mobile usability is back then. What should we make of the huge difference in conversion rates between desktop and mobile phones? One, the mobile user experience must be horrible. And he elaborates on that, but I'm not going to read all of that. Or two, it's not worth investing in mobile design. In other words, this is the kind of top UX expert just 10 years ago, talking about how mobile design, most of the websites were just so horrible that he kind of had to hypothesize of why it was so normal for it to be horrible. And now today, mobile usability in terms of accessibility is far, far better. And many folks who need assistive technologies report that it's come a long way, and in many cases is quite good. Okay, so that is human factors and how far we've come. Data visualization, of course, this comes from statisticians inventing ways to visualize data, and over time, inventing different types of charts, graphs, and data plotting techniques in order to bring these ideas into a format where we can take advantage of them visually. You'll see on this line, I have a split here because data visualization in theory, we know a lot about how to make data visualization very, very effective, very accessible. The problem is we don't use it in practice. And most of our experience with data visualization is dealing with very, very problematic graphics and situations that are very difficult for us to perceive and to make use out of. So that is a little bit of a lay of the land. So I think that just as accessibility, the need for accessibility helped mobile design. Mobile design is much further along today than it used to be. Most of our design toolkits in UX are really quite good nowadays. And most of it is owed to the agenda of making things more accessible. I think we can perhaps be hopeful that if we make accessibility more of a part of the data visualization framework, that we'll see potentially dramatic improvements in data visualization and the state of it. And so with that thought in mind, let's think about this. And I want to return to talking about some of the earlier examples, but first setting up this idea that I think is a useful and effective idea for thinking about this stuff. And that is the signal detection theory, okay? Signal versus noise. Signal detection theory deals with the idea of how do we boost the signal and reduce the noise, okay? And if we think about this in terms of what's actually going on when we perceive something, we're taking in bits of information. Every time we look at something or hear something, every time we, bits in terms of the measurement of information. Information is measured in bits. And so how do we increase the bits that are associated with the signal, decrease the bits that are associated with noise, okay? And this has special considerations dealing with what mode you're dealing with, right? So if you're visualizing, you can have parallel processing, right? You can process many bits of information simultaneously. With audio interpretation, like with screen readers, it has to be serial processing. You're processing each bit of data one at a time in order from beginning to end. And so those are some considerations when we're talking about bringing data insights. But with with signal detection theory, we're thinking about everything falls into kind of four possible scenarios for everyone who can't see this. Is I'm showing a quadrant with diagram with four quadrants. On the factors here are that a piece of information is either detected or not detected, all right? And a signal was actually present or it was not present, all right? So the possible scenarios you can have are a hit, a miss, a false alarm, and a correct rejection, okay? So if a signal was actually there and you detected it, that's a hit. And think about this in terms of, this comes out of like radar, in the military, or like scanning, scans if you're dealing in medical practice and things like that. Whenever you're looking at a display or experiencing a display and there's a lot of noise, you have to employ this kind of approach. All right, so you can have a hit, a miss. A miss is where there was a signal, but you didn't detect it. A false alarm means there was no signal, but you thought you detected something, right? And or you could have a correct rejection. There was no signal and you also didn't think there was a signal, all right? So that's signal detection theory, just to give you an overview of that. And when we're looking at that in terms of our framework, and we look at some of these diagrams. Now, for those who cannot see the slides, I'm going to be going through a few slides that are very, very busy, very colorful, and have lots of things wrong with them. Okay, so for this data visualization, this first one, we've got, we've got this area chart, we've got a pie chart that uses gradients of similar colors right next to each other to show categorical information. We've got lots of busy stuff going on. I won't go through all the details of everything that's going wrong, but what I'll point out is that from a signal detection theory, we've got too much noise here. It's hard to, where we need a signal, where we need to see it, to say on this pie graph, for instance, what are the differences between these slices of the donut chart? We're not getting enough signal. We're not getting enough of a distinction between the different things. And then everywhere else we get some, sometimes too much of too many bits of information where they don't map onto meaning. Here's another example. Again, won't go through all of it, but for everyone, it's just a super busy dashboard with lots of different types of graphs that are difficult to interpret. And just flipping through these here. But the point is that we have a natural way of operating when we're trying to visualize data. And it's whenever you're introducing variation, different colors that don't map onto something that's meaningful, you're forcing the viewer to contend with lots of noise, right? And it's very difficult for people to gain insights from these things. And here's a final example: a pie graph with exploding slices coming out of it, just very difficult to perceive. So this is data visualization as perceived by sighted folks. And then we see from the examples, or we saw from the examples that we started off with, we have problems across the board too. So with visualizations, too much noise, folks are doing data art when they should be doing data visualization, and so forth. Screen reading data visualizations is also very problematic. Folks are forced to express in the same way that you would experience a table. The screen reader goes through most often goes through each point of a line chart or each point of any kind of graph one by one, meaning that you're really not getting any kind of a benefit that would be associated with a visualization where you get some kind of parallel processing or some kind of a summary view of what's going on. And so even if the visualization is designed well for a screen reader, which is often not the case, it's still very difficult for folks to perceive these. Sonification, this stuff has not been standardized. No one, we have not collectively decided what different sounds mean and what changes in pitch and rates and all of that kind of stuff, what that all maps onto. That stuff has not been figured out, and it might be a while before we're able to figure that stuff out, even though it might be promising in the future. And it also still would likely require lots of training. Tactile graphics is absolutely brilliant and can probably solve a lot of problems. But today, Mona Mankara, whose story I've opened up with, who uses this technique brilliantly in her classrooms, still has to have an assistant use a glue gun in order to build the tactile visualizations before her classes. So it's as awesome as it is, we're not there yet for tactile graphics. So I would like to submit that the immediate solution would be innovations around captions. And now this is, probably not the, compared to the other solutions, not the most exciting, but I think that it has a good shot at being very successful. So captions, and we're going to look at some specific examples worked out, but the overall topic that we've got to get right is the HTML structure of the containing page. When we're talking about data visualizations, we want to make sure that the appropriate levels of the HTML structure are mapped on to the matching data visualization pieces. And so in other words, we want to make it so that a screen reader is able to process whatever we're putting in our digital interface. And so high level, what we're supposed to do, the H1, right? Heading 1, that's going to be your dashboard title. Dashboard, I'm using this as a very loose catch-all for what is the name of the overall page of visualizations. H2 is the view title. View, in many data discovery software, view basically means a data set expressed as some widget on your dashboard page. So that's what's usually called a view. So H1, that's the dashboard title. H2, that's your view title. H3, that's going to be your filters, your parameters, your sets, your legend title. Okay, and then the other details go in the caption. And so why are captions, why are we talking about the captions here as the solution? Well, one, it's very, very achievable. It's right around the corner, but it's also it's more effective than many of the proposed alternatives for the reasons that we've stated. Sonification, tactile graphics, lack scalability, lack standards that are universal. So, so captions, and we have existing skill sets that are around today that we could immediately hire for or exercise in order to make effective captions. Caption writing overview for this approach, I'm going to say have a clarity bias when you're writing these. These are overall kind of take-home messages before I show you the specific examples. You want to write with a clarity bias. You could different writers have different styles. You could write with a brevity bias where you're trying to make things short, a comprehensive bias where you're trying to cover everything. Here we want to think in terms of a strong clarity bias when we're writing. We want to think about summarization as kind of the main goal of all of this, and using redundancy when necessary. Because remember, this is serial processing that we have from the audio modality, meaning that we can benefit from some redundancy because we're experiencing each bit of information one at a time. Okay, there's kind of two competing priorities when we're thinking about how to do this. We can think about prioritizing describing the visualization versus describing the data. Okay, so if someone draws you a graph and you say, okay, how do you put this in an audio format? You can focus on describing the features of the visualization itself, or you can shift the primary focus on describing the data and making that clear, and then describing the visualization. And some of these examples will become clear as I'm giving you, as we're walking through some of these examples. Okay, so the first one, this is a bar graph, a stacked, ranked horizontal bar graph from top to bottom, big values at the top to the bottom. I'm saying that for folks who are not seeing the slide, and paired with a paragraph that is an example caption. Okay, so I'm going to read the paragraph, and then I'm going to break down the anatomy, the proposed anatomy of the caption. Okay, all right. So February jobs 1 month net charge is a bar graph ranking industries on job creation. Industries with the highest numbers of job creation are at the top, the lowest are at the bottom. From highest to lowest, the values are as follows. And then I have the placeholders X, Y, Z, and that represents where the graph values would be read by the screen reader from top to bottom. Okay, so let's take a look at the anatomy of what I just read. Okay, so we start off with the graph title. Okay, just to orient everyone, like what am I even looking at? What is this object called? Graph title as the first thing. Second thing, the graph type. Okay, so this is a bar graph. The third thing is the key objective of this graph, that we're ranking industries on job creation, right? So already within this first sentence, I'm fairly decently grounded on what I'm supposed to be experiencing. I'm somehow experiencing a bar graph, something about its structure, and then what's its objective. Now I'm going to orient the user around the display, because we're going to be reading information. So we want to be sure that the user is properly prepped for being able to interpret this stuff effectively. Industries with the highest numbers of job creation are at the top, the lowest are at the bottom, right? So we give an overall big picture of what's going on in this picture. And then we read the data at the end, and we orient them around that orientation for data read. Okay, so orientation of display, then orientation for data read. And that's from highest to lowest, the values are as follows, and then you read them, okay? Let's do another example. So the full text is long, so I'm gonna just read this. I'm just gonna go through the parts. And for everyone, this I'm showing a line graph, and a lot of this is actually gonna be described as I go through these parts. You know what, I'm gonna go ahead and read this and then go through the parts. Rising college costs is a time series line graph that shows the cost of college rising over time. All right, so we've got the graph title. Rising college costs is a time series line graph type, and then key objective that shows the cost of college rising over time. The graph compares 3 types of colleges from the years 1970 to 2020. Okay, so we're orienting people around what is the data doing. Whoops, so that's full text. So this is a continuation on the first part. The 3 types of colleges are private, nonprofit for college, private for college colleges, and public 2-year colleges. Now, Here, I've injected a new part. I'm calling it the data clarification. Here, what we're doing is the data itself might not be so easy to understand. It's not something that you can hear once necessarily and say, ah, I've got it. So what we have here is just a little bit of clarification around what's going on with the data. So here we say the tuition amount is shown on the y-axis. To be precise, it is the average amount that a student would pay in tuition and fees adjusted for inflation. Now, notice we didn't start this at the top. We started at the top with just kind of high-level orienting information. And we have to fight to get the important verbiage up toward the top, because the closer you are at the top, the closer a word is to the top, the more likely it is to be read, right? Because folks are going to drop off. They're more likely to drop off as the reading continues. So you want to make sure that the most important stuff in terms of understanding the data is moved up toward the top. So that's our data clarification. And then orientation for data summary. And I'm going to talk about why I've got a data summary here and not a data read. The data are in 2019 dollars. The data are in 2019 dollars, excuse me. Here are the trends from highest to lowest from 1970 to 2022. Now, notice what we're doing here. What we're doing here is we're not going to be going through each of these lines and point by point reading what the value of each of those points is. That would be the same thing as just reading a table. You might as well not have a data visualization if you're going to be doing that. What a sighted person gains from this data visualization is that they can immediately see the shapes of the lines. And that's the purpose of a line graph, is so you can see the shapes and you can interpret that as some kind of a trend or some kind of properties of that data series, okay? We want to give the same experience or similar experience to our non-sighted users. So we've got public 2-year colleges. So here I'm going to read through 3 points that represent the 3 lines. Public 2-year colleges start at about $1,000 in 1970 and rise steadily to around $3,000 or $4,000 in 2020. Private nonprofit 4-year colleges start at $10,000 in 1970 and rise steadily to almost $40,000 in 2020. Public 4-year colleges start at a few $1,000s in 1970 and rise to about $10,000 in 2020. Think about, now, I want everyone who's listening, think about how much easier that is to interpret than a screen reader going point by point and reading the actual values of each point on the line graph. Now, of course, this would take extra work to be able to create such a thing. But for the enterprising entrepreneurs out there and folks who deal with, technologies that produce speech and artificial intelligence, what can we do to potentially produce this kind of summary, maybe automatically in the future? That's something to think about, isn't it? But in the meantime, we can still immediately act on this. If you have a data visualization that's not dynamic and that it's fixed and you're putting it on a website or you're going to be displaying this somehow, this is totally an option to be able to use this method. Okay, so this next example, I believe this is the final example. The next example is showing a choropleth map. That is a map that uses colors to show density of data. And this one is bipolar, where it shows blue for very, very low rates, a neutral color, in this case, white or kind of a grayish color for a neutral rate, and then deep dark red for the high rates. Okay, so I'm going to read through this. Corporate tax rates around the world 2020 is a choropleth or heat map of a world map. And for everyone, as I'm reading through this, I'm clicking through the slides and it's showing the anatomy. So that was the graph title and the graph type. The visualization illustrates the corporate tax rate of each country in the world. That was your key objective. High rates are displayed in a reddish tone, while low rates are displayed in a bluish tone. Dark saturated colors represent extreme values, while lighter colors, closer to white, represent moderate values. From left to right, this map can be summarized with the following characteristics. North American countries have relatively high corporate tax rates, and with Mexico being slightly higher. South American countries have relatively high rates with a few exceptions: Ecuador, Chile, Bolivia, and Uruguay. And you kind of get the idea, right? So we set the scene for being able to describe the data as naturally as possible. We start with the most important information that the viewer cannot do without. And we describe things in more of a storytelling kind of way. And we are getting to the actual point of data visualization. The point of data visualization is not to end with an image, a visual image. The point of data visualization is to transmit insights from one human mind to another. And so I will, we're at near time, so we're gonna leave with that as kind of the overall, as the take home, but essentially we're dealing with, in the topic of data visualization, let's think first about communication, and let's think about ways in which the technology can support our ability to communicate data with each other. And I've offered a few frameworks for thinking about this, but I think the take home is that we want to end up with everybody being able to benefit from insights. Thank you very much.
Great, thank you, Thomas. We do have some great questions in here. And so since we have about 6-7 minutes, I'm gonna field a few of those for you. Do you want me to read some of them off to you, or do you want to just kind of grab some? What would you prefer?
Oh, okay. So I do see the questions. Do you have any priorities? Otherwise, I could just kind of jump down, go down them.
Yeah, just go for it. Yeah.
Okay, so the first question is, do you recommend captions over alt text for describing data? I think that so this is a good question because it deals with kind of the difference between where alt text used for, which is, used for images, right? So that's something that can't be perceived otherwise than someone doing alt text. I think as long as the screen reader is going to get the summary to the viewer, to the listener, that's what matters. Now, for folks who work very deeply in this area, the difference between when alt text and captions would be played by a screen reader, that can be commented on more specifically by someone more specific with it. But what you want is it to be able to be to go right from reading what the visualization is on into describing it. Okay, so is this deck shareable by any chance? Yes, I will be sharing the deck. I'm not sure to who, but I'll share this out with the appropriate WebAIM folks. How do we deal with dynamic reports and that change over time? Yes. Okay, so that's going to be a very big challenge. This question is, how do we deal with dynamic reports that change over time and as more data comes in? Issue with the captions that they have to be crafted, not as scalable. So that it is absolutely correct that this has to be crafted today. Today, I do not see a neat way to have this automatically happen with dynamic displays. So for example, if you're looking at a dashboard or any other information display where the data may not be the same from day to day, from second to second. So that's where the proposal to encourage entrepreneurs or folks who work on projects, what can we do to use AI and natural language generation to be able to interpret some of these things and deliver these kinds of summaries? So that would not be immediately available today for the dynamic instances. And but unfortunately, neither would sonification or some of these other things. So that's something I think to very, very much think about. What do you suggest for captions for data visualizations that are adjustable on the fly? Yeah, I think this one's going to be similar to the other one because we're dealing with the dynamic factor. Yes. Okay, so isn't this too long for alt text? Yeah, well, so it is long. So that's why I had it there as captions. But it's long. The challenge is, and you do want it short. The challenge is, how do we deliver the insights so that folks who are not seeing this can benefit from this? Okay, about 150 characters was the recommended limit. Yes, that's a recommended limit, but what I would say is that here we're using a clarity bias and not a brevity bias. And so it has to do with what the priorities are. Bob says, I would question if a line chart is properly accessible with only trend interpretation. I would expect a blind screen reader user to have access to points on the graph in addition to the, so I 100% agree. The part that I forgot to mention about that is that I think the data read could be saved for last for those cases, but that you still have the data included. So thank you for saying that. And we've got, okay, do you have sample code or integrating captions in existing dashboards, web maps, etc.? Unfortunately, I don't have sample code. So the closest I've seen to just good accessibility, Tableau does an excellent job of thinking about a lot of different factors of accessibility. And it's not quite as advanced as some of these proposals that have been pitched in this deck. But no, I don't. The answer is no, I don't have it. Hopefully more of that kind of stuff becomes available as time goes on. Most of the dealing, Patrick says, most of my dealings with cloud providers that allow configuration, but limited customization. Yes, that is correct. And even when you can customize in data discovery tools, it's often quite difficult. So yeah, that continues to be a challenge.
I'm going to cut you off, Thomas. We're at the time because we've got people get to the other sessions and that, and I got to wrap up. So
okay, great.
Switch the screen, but a couple of just end things, like if people wanted to follow your work, what's the best way for them to follow you?
Find me on LinkedIn, Thomas Watkins, and you could also go to my website, 3leaf.consulting.
And then the last question I had is, I told someone earlier on, I would ask this at the start. You shared a story of the lady with the lithograph. Yes. What was her name again?
Yes, her name was Mona, M-O-N-A, Mona Minkara, M-I-N-K-A-R-A.